Good morning. Have you seen beach? In the beach the water is moving, isn't it? In which form the water is moving in the beach? Yes, the water is moving like a wave. So students, today we are going to learn about waves or wave motion. So it is very important topic in physics. So let's get started. So first we are going to discuss about what is wave motion. So for that, consider a case of a pond. When you throw a stone in the pond, what happened to the water? When you throw a stone in the pond, what happened to that water? Yes, you can see some ripples. That is, the ripples start forming and it travel from one point to the other part of the medium, isn't it? So again consider the same case. That is, first the water is in the pond is at undisturbed position or equilibrium position. That is when you before you throw the stone, the water is at undisturbed or equilibrium position. Then when you throw a stone, you are producing a disturbance on the water, isn't it? When you throw a stone, you are producing a disturbance on the water by using the stone. Okay, so due to this disturbance, the particles in the water starts vibrating, and that vibration of the particle is moving from one point of the medium to other part of the medium. So this is called what? Wave motion. So clear? So wave motion, actually the actual matter is not moving. The vibration of the particle is moving from one point to another part of the medium, or we can say it is a transfer of energy. Okay, the vibration means what? The particles start vibrating. That means what? The particle gets some energy. Okay, so that energy is transferring from one point of the medium to another part of the medium. Okay, so it does not involve the actual matter of the particle. Energy travels through vibration or disturbances. Clear? So the wave motion means what? The energy of the particle is traveling from one point to another point like a vibration. Okay, clear? So next we are discussing about the types of waves. That is, depending on the medium of propagation of the waves, we can divide the waves into two types. First one is mechanical wave and the second one is electromagnetic wave. So mechanical wave means what? The mechanical waves need a medium for its propagation. Okay, so it's need a medium for its propagation. So this type of waves will only travels through a medium. Okay, so example, sound and water. Next, electromagnetic wave means it does not require a medium for its propagation. Okay, so example, light and radio waves are the example for electromagnetic waves. Okay, the next classification, we already discussed one type of classification, that is mechanical wave and electromagnetic wave, that is depending on the medium of its propagation. Okay, so this mechanical wave we can again classify into two type. Okay, the mechanical wave we can again classify into two type. The first one is transverse wave and the second one is longitudinal waves. Okay, first classification is transverse wave. So what is the difference between this transverse and longitudinal waves? Just discuss. Okay, so in the case of transverse wave, the particles vibrate perpendicular to the direction of the propagation of the wave. Okay, so here the particle is vibrating perpendicular. See, just look at this picture. Here you can see the wave. Okay, see, the mean position. This is the mean position of the particle. Mean position means what? The particle is at rest. Okay, the particle is at rest position. It is not vibrating, it is at rest. Okay, then after start vibrating, when the vibration starts, the particle starts vibrating. How? Perpendicular to the direction of propagation. Okay, that is, this is the direction of propagation. In this direction the particle is vibrating. So in this direction the particle is vibrating perpendicular. Okay, the particle is vibrating perpendicular to the direction of propagation of the wave. So that is known as transverse wave. So in the case of transverse wave, we can see continuous crest and trough. That is, crest means this upper cycle is known as crest and this lower portion is known as trough. Okay, so in the case of transverse wave, we can see continuous crest and trough. Okay, then example for transverse wave: light wave and water waves. Okay, then longitudinal wave. Next wave is longitudinal wave. So what is the difference from transverse wave? Okay, so longitudinal wave means the particles vibrate parallel to the direction of propagation of the wave. Okay, here the particle is vibrating parallel. Okay, so just consider this picture. This is the propagation. In this direction the wave is propagating, in this direction. Okay, so here the particle is vibrating parallel. See, in this case you can just consider the case of a spring. The spring is vibrating in parallel direction, isn't it? So same here, that is the wave here also, the particles vibrating like parallel. Okay, parallel to the direction of propagation. Okay, so in the case of longitudinal wave, you can see continuous compression and rarefactions. Okay, continuous compression and rarefactions we can see in the case of what longitudinal waves. Okay, clear? So example for longitudinal wave is sound wave. Sound waves are example for longitudinal waves.